So, hello everybody. Welcome to this another episode of A Day in the Life podcast. Today I have Mr. Avinash KR with me today. So, thank you, Avinash, for being here and sparing your time for this discussion. So, let me give a quick introduction to Avinash. So, Avinash is the COO of Vyoda Private Limited. Okay, it's an agri startup and it's part of the NR conglomerate group. Okay. And I think the key achievement for Vyoda and Avinash is I think they have developed world's first solar-based positive displacement piston pump. And I think we'll understand from Avinash what that is. I think that is for enabling farmers to grow more and get better yields, and we'll understand how that helps and how that works from him also. But other than that, he has a very long stint with Bosch, more than 18 years, where he has played diverse roles from manufacturing, quality, as well as sales and marketing. And after that, Avinash moved into NASSCOM's the R&D vertical, where he was responsible for developing the IoT COE, I think, which was well known for a lot of other initiatives at that time. And he's also helped create special interest groups in the aero, auto, and construction verticals. So welcome, Avinash, and thank you for being here.
Yeah, thanks, Chinmay. Thanks for the introduction, Chinmay. Nice to be with you and nice to talk to you after a long time.
Yes, yes. I think so. I have had the privilege to work with Avinash during our entirely some small initiatives that we did that time, where I got to know him. Thank you, Avinash, for being here. And okay, let me just start with tracing your journey, right? So you are a mechanical engineer, and I think you also followed it up with an MBA. So tell us briefly about your stint at Bosch and how was that? You worked there for 18 long years and you did various roles. So tell us something about that. How was that experience? And what was your key learnings from that experience as a mechanical engineer?
See, I passed out in 1995 as a mechanical engineer from Bangalore University. During that time, if I don't know how many of you know, the Y2K was at the peak that time because
Oh, yes. Yes.
people were worried what will happen in 2000. The lifts will stop working.
Yeah, yeah.
The whole US will stop working because everyone had that last two digit, no, 00 was there.
Zero,
And
zero. Yeah, yeah, yeah.
so what happens after 1900 becomes, and so that time what happened is any engineer coming out of college, irrespective of which branch he comes from, they were hired by these service industries and they were taken and they were just sent to US. So that was a big buzz during when I passed out engineering. So because in US, if you want to go to US, you should have 16 years of education. So an engineer only had 16 years of education. Rest all graduates had only 15 years. So they were not
Ah,
eligible to go to
okay. Okay.
US. So any engineering, if you are chemical, civil, mechanical, it doesn't matter unless you are an engineer. If you have a engineering graduate was there. I was fortunate. I got joined Bosch as a graduate deputy. I always loved automotive, so automotive
Okay.
was always my passion from the child. So where I joined Bosch, and Bosch was supposed to be one of the dream companies to join because of automotive. I joined Bosch as a graduate deputy trainee. Worked in various departments for 6 to 8 weeks in different departments. Worked there,
Okay.
understood roles. It could be from production or production control, purchase, quality, everything. I worked there for 6 weeks, understood. I was fortunate then Bosch confirmed a couple of us in that group, and I was the one guy who got confirmed. And then I was assigned to department where they were manufacturing single cylinder pumps. So these were single cylinder pumps, which was done at Naganathpura plant of Bosch.
Okay.
Uh, Fresh engineer out of college in just 1 year of different as a graduate apprentice, you don't you know, but you don't do any hands on there, but you still
Right.
understand go different department, understand how the functionality of the department was, everything. So then I was pushed to the production, and production in Bosch is quite challenging because there's a union. Then you have manufacturing, everything happens there, and you are always against the time running there. So I was given a very small department where there was 12 operators and three components were produced. So I was made responsibility of that one small shop, very
Okay.
small shop was there. So and in that time Bosch was still doing a lot of in-house manufacturing of components.
Okay.
After that, most of them got offloaded, but during that time, still 96, 97, a lot of components
Mhm.
were still manufactured in-house at Bosch. So there are three small components. All the three components were going into a single cylinder pump, or they said a single cylinder pump, and these were getting exported to Europe.
Okay.
So single cylinder pump, just to give an understanding what does it mean is all your diesel pumps which you use for pumping water out, you got
Okay.
your auto rickshaws, then your small generators, all those are being used in diesel single cylinder pump.
Okay.
So we were doing, I was responsible for manufacturing components, three components out of so many components for doing it. So that is how I started journey. So young blood. So I still want to give an example. There was a issue. There are some quality issues happening there. So I
Mm-hmm.
wanted to see what is the problem in the fixture. So completely dismantle the fixture. Could not
Okay.
assemble it back
Okay.
because dismantling is easy. Assembling it back.
Something like that.
And that time you did not have drawings, everything on your
Okay.
laptop. So all the drawings
Ah.
there in the machine building was in Bangalore campus. We were in Naganatpura, just 10 kilometers, 12 kilometers apart. So you had all these drawings, big size A0, A1
Ah.
drawings. You have to take a blueprint, bring it, and then you have
Wow.
the assembly drawing, the component drawing, everything has to be done. So got all the drawings. So I had a colleague who also was heading engineering during the time. So we both worked. There were a lot of components were worn out in the fixture, everything. So we took 2 days to assemble it back,
Something back.
and the production was stalled. The line was stopped. The assembly line was stopped. So I mean, it was a risk I
Correct.
took knowingly, unknowingly. But later, once we assembled, we got the few components which are, I mean, I was talking components in the fixture which was worn out. We got the new one done, assembled it back.
Mhm.
We could see that the quality improved substantially.
Oh, great. Fantastic.
So that's the motivation which give then okay we can do this one. So
And
then there were 6 operations were happening. So we said let's not make this the effort. So we first got the drawing, then understood drawing, then got the components, and then we started replacing for all the machining process. So all the 6 we assembled, and so when I took up that department, there was like 85% was getting repaired. The components, 85% of the component was getting
okay. Okay.
the rest 15 was getting scrapped. So by the time we completed the project in 2 years, 100% was first time yield, first pass yield.
Oh, first class. Great.
So I would still say that is a big achievement as a youngster. What
Yes, yes. Phenomenal.
was and that's appreciated. First pass yield has increased. The quality had a good yield, and there was no rejection in the line because every time we used to have a rejection in the assembly line, come back, do rework or repair or
Mm.
quantity short, running short. All those things were at least went out, and 2 years down the line, we were able to bring it to 100%. So that is
Amazing.
where started. So for the from that, so that was a good recognition also as a youngster doing it.
Correct.
So then I was given additional responsibility of one more component department was added to me.
Mm.
So I was made a department head. Within 3 years, I was made a department head, and I don't know if it's a boasting myself or not. Two of the guys who are at 50 years of age, who are 25 years of experience, were asked to report to me.
Oh, okay.
And
Wow.
one was for 25 years. I mean, they were non-engineers, but still they came up in the ranks. I think they were asked to report to me, which that happened in 3 years. And the end of fourth year, I was made in charge for the complete components manufacturing, which
Oh,
had
wow.
72 operators and 6 foremen reporting to me.
Oh, wow.
So kept on improvising the quality, production, everything we did everything, and almost I worked in that department for 6 years. I worked in the department. 6 years I worked in the department there. Then the last seventh year, I was given a responsibility of offloading all the components to the vendor. So that the time, so I worked for a year to establish the same component with the same quality outside of Bosch,
Incredible.
because
Mhm.
we wanted to get the same quality getting in it. So 1 year I ensured that where different vendors were established and we uploaded all the components outside and the same quality was achieved.
Mm-hmm.
So nutshell, what I can tell, I still know the component number. I still know the dimensions of with the tolerances of these components.
Okay.
And if somebody says there is a wrong in that, there's some issue in that component, I can tell what is the problem. And
Oh,
it's almost like 20, 25 years now on that.
so wow, you have really got into the heart of it then.
So what I want to tell is, if you are able to, if you go deep into a subject, understand the subject, you will never forget. It is like, no, if you learn swimming, you cannot forget swimming after so many years.
Correct, correct,
But
correct.
you cannot learn swimming standing outside a swimming pool. You cannot learn swimming watching a YouTube video.
Right, true, true.
So
So you have to get into the water, you have to dirty your hands,
you
you
have to
have
drink water, you have to get drowned, you have to
that.
call for help and everything. So that is what has learned thing. So two things. One is, of course, on technical front, what it teaches you technically, what it teaches you understand technology, to understand
Right,
uh,
right.
what's happening. So today also, if somebody comes and tells me that this is not happening, that is not happening, I know what's the reality, because then you can always tell this is a problem there in general manufacturing.
Mm. Yeah,
Everything.
understand.
So people
Mm.
cannot fool around you on this case.
Correct, correct,
This is
correct,
on the technology front. But if you're a manufacturing or a production thing, it also teaches you management, man management.
correct, correct.
So when you're handling production, I said, no, I had some 72 employees,
Mm.
blue
True,
collar job and then six white collar job. So you handle these two in a different manner. The
correct,
blue
correct.
collar job are always being supported by the union. So any wrong word you use, it can bring the production down. They can put the tool down, and there can be chaotic, and all those things can happen there, and
Mm.
which will be responsible, held responsible for it. And other hand, you cannot be so naive and stop that the production does not happen.
Mm.
So it
Correct.
teaches you the man management, both the man management. One is the white collar officer job, and then the blue collar job.
Mm.
And there is no hire and fire policy there. So you have to go along with them. You have to help them. You have to support them. You have to be clear what's your goals and what responsibilities you present, what the company needs. So it
Mm.
teaches you both the technology as well as man management when you're in a production environment.
Interesting. So, how was so? I mean, nobody teaches you man management, right? In colleges, college is for technical education only. So, I mean, coming to the context of today, I want to learn from you. Like, is there any way where students who are joining the industry, because this is part and parcel of the job, right?
Correct.
Uh, what is it that are qualities that are required to from the softer side, to when you are in a production environment, in a manufacturing setup where you have to work with a lot of other people, blue collar, white collar, everything. What is the mindset that is required to ensure that the job gets done?
You are really picked up a nice question, because nobody talks about this man management in the colleges. In the
Correct.
engineering, I don't think the syllabus will have changed from the time I studied to
Yeah,
now.
I
Apart from
believe so.
some robotics and all those things, rest all would remain same. The basics of mechanical engineering will remain same, and not in mechanical engineering, any engineering for the matter. If you are a
True.
electronics, computer science, nobody teaches you man management there. So this two ways to do it. One is there could be from the industry side where people go and talk only about man management, because see, these things come with experience,
Correct.
especially man management. No, you cannot, as a same self,
Cannot teach.
like
You
same,
have to get into the thing.
you
It's
have
like
to get
swimming,
into the
as you said.
stream. You have to get into the stream, but at least you can know some soft topics or soft
Hmm.
skills you can understand from the. See, I was lucky enough where when I joined, no, I had few bosses who taught only man management. I don't say,
Oh.
I mean, I can put it in man management. For example, one of my, when I joined, the first thing my boss told, he said, Avinash, you are handling labor here.
Hmm.
You help them for 99 times. You go out and help them. You
Hmm.
don't help them for one time. They'll be only talking about the one time which you are not helped. They don't talk about 99 times you have helped, which you have done out of the way and do it.
Hmm.
So, whatever you do within the boundary condition. Don't deviate from boundary condition. Nobody can tomorrow question you that you're out of that boundary or out of that process, whatever you are talking about it. It has to be as per the rule.
Hmm.
So if you are following as per the rule and you are doing the same rule across the board, then nobody will complain you. Because the rule remains same. For example, if I jump a red signal, you jump a red signal, it is same. It cannot happen, okay, Chinmay, you jumped red and you were there. No, red is red for you. Red is red for me also.
Right. Got it. Got it. Got it.
So, but if you are touching the zebra line, you are stopping at, you're touching zebra line, okay, you are not on zebra. So that you should know where to have that thin line of.
Got it.
So when somebody crosses the red line, it is offense. Immaterial of how good what it is.
Got
So
it.
these were, I mean, these were taught to me when I joined. I was happy that I was lucky enough when they joined this thing. And I also don't keep any financial transaction with your employees.
Okay.
Typically, people do that mistake. They have this. Then you are obligated.
Correct. Correct. Correct.
See, if you are having a financial transaction, then you get obligated. Then you have to say they. So you are obligated.
Yeah. Yeah.
So don't have financial transaction. Everything has to be within the rules. So you have within the rules and keep the rules. So when you have rules, easy to follow. When you know the rules, easy to follow. So you need not worry about what should I do. So you have a rule book, you just follow the rule book.
Yeah.
But if these things are taught to student by the industry, because college professors typically teaches the technical technology. They also would have not seen. I'm not praising, but at least majority of the college professor would have not seen industry.
Yeah.
So since you're
So
not
actually,
in
yeah,
industry,
on the ground experience actually will be the best teacher in this case.
if you are not driven a car, you don't know what is a signal means.
Yeah.
If you're always sitting in the bus and just driving, you don't observe what's a signal, what is the rule I have to follow while driving. So if you get from the industry, and the industry guys should more talk about these soft skills, how to behave, what happens to union, what is the union, all those things, and
Yeah.
then how to manage this soft skill and thing. That could be a great insight to the student when they come to the manufacturing. Because see, then we come to R&D also, but still they have to go to the production shop to talk to people, talk to the employees, all those things, not to blue collar job. So, for example, I was told never ever use any bad word in the context. So, never ever use it. You have to be very mindful. You have to be very conscious when you are talking.
Correct.
Because whenever somebody irritates, you typically you say a bad word. It could be.
You
You may
can.
think it's not a bad word. It's a normal slang, but it could be a bad word.
Yeah, you
So,
have to be very conscious with the communication also.
so when you're talking, you have to be very conscious about communication. Don't use bad word. Don't use singular. When you're especially arguing, don't use singular.
Yeah, yeah,
All
yeah.
those things become a big issue there.
Right, 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 right.
I mean,
Interesting.
I've faced all those things, but most of the times I've been sailed through because I was right always I was always on the right side of the path.
Because yeah, I think I think the learning, I think what Avinash is saying is stick to the rule, follow the boundary and what the process is driven and stick to it, irrespective of who we are. Right. So no concessions there, and everybody then understands how you work. I think that's a fair rule. So, Avinash, from here on, I see that you also looked at and took up various different kinds of roles other than manufacturing. You have quality and I think sales, and you have talked about it. So, was this a conscious transition within Bosch itself?
So after my manufacturing stint, I had an opportunity to go to Germany for 3 years
Okay.
to manage customer quality in Germany, both German and Italian customers. So to get to that training, then I moved to quality department for 1 year in Bosch in India to understand the quality process. How does it happen?
Okay.
Handling Indian customers going there before going there, because quality, there are two things. One is your process quality, and then is your customer quality, which are two different things. Because customer quality is different and process quality is always internal. So you handle your process quality, and I think when it comes to customer quality, once again, then your soft skill comes to major role than your
Right.
technology technical. Of course, technical skill has to be there, but your soft skills also comes to a big role there. So I was given responsibility here for 1 year. I managed both Indian customers and then process quality. I managed both process quality and Indian customer quality. Then I went to Germany for 3 years. So
Oh,
I was
nice.
asked, yeah, I was given an option if you want to do it. I said, okay, since I had done almost like 6 years of manufacturing, which I had a strong technological background. So I said quality would be a
Yes.
natural progression. Then because you understand the manufacturing,
Actually, now you.
you move to
Okay.
quality. Then see, typically what happens, I've seen people who have been in quality for from long without having manufacturing industry, they once again go with the rule book.
Oh,
Yeah.
okay.
So what for them, assuming there is a component which is 10 mm plus minus say 0.1 mm,
Hmm.
for them 0.01 is not okay with them because
Oh,
they go with just as per the drawing, it has to be the thing. It is not
yes.
as. But when you come from manufacturing, then you understand how much impact it will happen.
Right, right, right,
Is this going to impact functionally because you come from manufacturing? You understand functionality of the product.
right.
Then you can take a conscious decision. Okay, this can doesn't have a customer problem. You can always
Hmm. Hmm.
as with concession. You can always give a concession. You can ask for the return agreement to the manufacturing, and then you can always pass it. Just rejecting the component, you are not a policeman. Just to say okay, not okay.
Ah, got
You
it.
have to
Got
add value to it. So when you are having a manufacturing background, your quality you can add more value to quality than just being a policeman there.
it. Hmm.
And then when you go to customer also, when there's a customer issue, then you can always tell the manufacturing guys what would have gone wrong. Then just saying, okay, there's a customer coming, please give me the reply for it. You can
Hmm.
be more of a team member than being a policeman there. So I went to Germany for 3 years handling these customer. When I went there, there are a lot of issues with our pumps in customer, but after going there, I understood the 80% of issues were from the customer end, not from our end.
Oh, okay. Interesting.
So the
Ah.
customer had issues, and he had his internal issues, and he had his quality issues, all those things.
Hmm.
So it took almost a year for me to understand what was the issue, then prepared the complete, I would say, the write-up presentation, working with the Indian team, the time working with German team. Uh, so then we went and presented to customer saying that these are the things we found, and 80% is lies on your table, not on Bosch. You are just blaming Bosch because simple. No, it is not working. Then throw to Bosch, throw on Bosch. That
Yeah, correct.
no,
Yeah,
no.
I think
For them it
the
is just for you.
customers, it's easy for them to do that.
Yeah, so they just pushed it and they said, then they understood, okay, okay. Finally, the customer complaints, which was in a big numbers, came down also to almost to zero.
Oh, wonderful.
Because then customer thinking was thinking twice before sending it as a Bosch problem. So he used to do internal checkups, and then so that started getting sorted out at
Okay.
his stage itself.
Hmm.
So once again, here I would say this was a soft skill which we did. So first is created the complete technical documentation on the what were the customer issues, why the issue was coming. Then proved it technically it was not Bosch, it was customer issue. So got the support from the Indian team. Then convinced the German Bosch team because they were of the opinion that all the Bosch is coming from Bosch India problem because the parts were supplied from Bosch India. So their
Okay.
opinion, India is not producing well. India had a problem, although Indian Bosch had a problem. So convince because we had a workshop in Germany, our own workshop of Bosch India workshop in Germany. So took the Bosch team to our workshop, showed it, demonstrated that in the workshop is as all everything is as per the drawing tolerances, everything, and customer is unnecessarily rejecting it, and the Bosch German team was convinced. Got the Bosch Italian team also to Bosch Germany, convinced them. So first we wanted to convince our people before going to customer.
Right.
Then as a team from India, Germany, Italy, we went to customer because then all the Bosch were on our side, of the Indian side.
Correct. Correct.
So when these were guys were convinced, then they could talk to customer more aggressively. They were more aggressive at that time.
Hmm.
Till now, we are telling it's Bosch problem. It's not Bosch because we are all Bosch, one Bosch that
Correct.
time.
Correct.
Till
Correct.
then, that is all Bosch in Bosch India issues. So then convinced, they all convinced customer. Customer acknowledged it, and then he said, "Okay, it's all now. We'll take care." So once again, work with the customer to see that it is their problem also. Not that we just push the problem and leave it there. So finally, worked with the customer and proved and helped him to solve his own problem. Finally, because it's a win-win for both of us. It's not that I prove I am right and no, you are wrong. It's not the case to do it.
Exactly. Exactly.
The idea to solve the problem, root cause, and ensure that the customer is also happy there. So could achieve that as a big achievement. I would say we did there. So then after that was done, 2 years I had a aram life. I would say I did not any problem there. So enjoyed my life in Germany.
So I think that's a very good example. I think Avinash, I think from that example, I think what the key learning I could draw was one is how important is stakeholder management, understanding the roles different stakeholders play And as you rightly said, it is not about proving I am right, you are wrong kind of a scenario. In the end, I think we have to really understand the larger picture and ensure that different relationships stay good, and the overall problem basically needs to be solved rather than shifting the blame from one side to the other side. We don't really have to play that game. I think that's a very good learning that you shared. So I think 18
Here,
years
just
is a
just to add here one more soft skill. What I was being taught by the predecessors when they were there.
Hmm.
They said when you go to customer, see typically what happens, no, in the customer quality, or general Indian, general human tendency is if you tell a Chinmay, it is not my problem, it's your problem.
Yeah, yeah.
Sorry. You look at Chinmay, it is your laptop could be an issue, your power should be an issue, network could be an issue. I never said there is an issue with my product. I always said, Chinmay, look at it. You look at it.
Hmm.
So when you, as a customer, as a vendor, if I tell you on your face, you get irritated.
Yeah, yeah.
What is this person? I'm telling him my problem. He's rather than solving the problem, he's trying to say it's my problem. So the first thing I was told is when the customer tells there's a problem, accept it. Okay,
Okay.
okay, there's a problem. Let you next. So you bring back your system component, whatever you bring back your product to your factory, investigate. Investigate is that is your problem.
Hmm.
Typically, the mindset is investigate, assuming that I
Hmm.
want to prove Chinmay is wrong.
Right, right, right,
Our mindset is always Chinmay is wrong.
right.
I'm not, I'm always right.
Hmm. True, true. Got it.
So when you investigate, when you do the thorough analysis and then go back to customer, say, see, this is what I've done investigation.
Hmm.
Now this is what is my report. Can you look at your report?
Right.
You always do the way. Let's you look at your component, you look at your bore, you look at your dimensions, you look at your. He gets irritated.
Correct, correct,
And his
correct.
mind gets closed. Then he wants to prove that I'm wrong. So it
Ah,
becomes like a
right.
who and who is
Who
right.
was
It
right, who was
becomes
wrong?
more a ego fight than a problem solving.
Right, right. I think that's what we need to avoid. Avoid. That is
So
fair
that
enough.
is one, I would say, lesson which soft skill people has to learn when doing
True.
customer handling, especially customer handling. I have seen a tendency because I do have some, we do have equipment at home. No? When you call them, oh, sir, this would be wrong in your equipment.
True. I think that's it's easy for customers to know do that to vendors because I think they can put them under pressure because they are buyers. But I think it's fair enough. I think we have to prove. I think the game is to ensure that your side is foolproof. As long as you can create that evidence
Correct.
and bring that investigation, I think it's fair enough. I think that's the good learning for kids. So I'm going to relate it back, Avinash, to today. Uh, you are continuing in your field. You are in your area, working in your area of strength. But instead of, I'm going to look at what kind of roles are there today for mechanical engineering. Do you think the industry has evolved? What kind of evolution from a mechanical engineering perspective is there in the industry today? And therefore, do you see any change in terms of how people need to orient themselves technically and soft skills wise?
See, fundamentals cannot change.
Hmm.
For example, fundamentals cannot change. People may talk about AI is going to take away all those things can talk. But if you want to move a car, you need four wheels. If you want to move a car, you need a power to move. It could be electric power, it could be IC engine, it could be hydrogen, anything. But you
Hmm.
need moving parts.
Correct, correct, correct.
So until and unless you have a moving parts, a mechanical would be there. And I don't at least see next 30, 40 years that we'll go away with the moving parts.
Um,
So the approach would be different. So the moving parts, until the moving parts are there, mechanical
is there, of course.
is there. And see, for example, somebody talks about AI. So if I just go back here, AI has to work on a GPUs.
Correct.
So you need GPUs to be installed in a particular rack or anything. So you need mechanical there. So that has to be cooled. Then you require coolers, chillers, all those things to be there. The
Um,
GPS has to move to a place. You need transportation to move it. If you are putting GPU inside a ocean, you need huge cranes to put into a ocean, take it out of the ocean. So anything you have to do, you need mechanical. So anything you are doing mobility or anything you need to move, you need mechanical industry. The
mm,
one good thing is, see, the mundane jobs could be reduced because of AI. What I mean mundane jobs is, see, when I started my career, where there was the drawings, we used to go and take the printout of the drawings from
mm,
the, take out the rack, take the original drawing, make a blueprint of it and bring it to a shop. And now everything is just a click of a button, you can see it on your laptop. that would have changed. So mundane would have changed, but still somebody has to create a drawing. See, or in the earlier days, if you have a drawing to do a CNC programming, somebody has to look at a drawing. They need to isolate, okay,
Mm.
where to start, where the reference point, what to come next. Now you have a program where you have a 3D model, just push it to a CNC machine, it creates its own program. So
Mm.
these things, I would say, the more of a operational mundane job could get eliminated. But if somebody is looking at a designing a product,
Right,
AI cannot do it.
right.
I
Mm.
will just give an example in my existing scenario. You were talking about our positive displacement piston pump, no? If I talk to anybody piston pump, because it is a submersible pump, you talk to any expert, the first question they ask is what happens to sand? Because there's a piston there. So if
Mm.
sand goes inside the piston, obvious answer is piston will get jammed.
Mm.
Piston will get jammed. So that is all. It's no brainer for anybody to do it. It could be you need not
Mm.
be an engineer to ask these questions also. If I go and ask you, so Chinmay, how do I avoid sand particle? Or if I
Mm.
ask anybody for matter, AI, how do I avoid sand particle? The obvious answer would be add filters.
Mm.
You had filters, you can have like going to HEPA filter where you have all those things, you use it there, or you have a nice filters which you use in your water
Mm.
purifier, no? Where you
Correct, correct.
don't get
Yeah.
any sand there, all those things you
Mm.
do it. That's the obvious answer. People will use it. Okay, fine. I can put it in the borewell, but that will get clogged within 1.5 months
Ah, correct.
because there's a lot of particles
A
there.
lot of particles. Yeah, yeah, true. Then
Once
again, you
it,
have to keep maintaining it like
once
regularly.
it gets
Such a
clogged,
headache.
there's no input. The water pump will stop
Yeah,
working.
yeah, correct. True, true.
So filter is a
That is
easy.
not the best solution, obviously.
No, if you just you go to AI, ask what will happen, you'll just say put a filter there. So what filter, how much improvise? I mean, you can put a best filter available, but the question is, it will only get clogged. But people that will not think that it will get clogged, and every 2 months I have to take out the pump, clean the filter, and put it back, and nobody wants to do it. This one, which is not, it is a cost.
Cost, yeah, yeah,
So,
obviously.
so that thinking AI is what it's the data available. It gives the best yeah,
Correct,
solution available to it.
correct,
But we
correct.
have developed a thing. Assuming the filter fails, still
Mm.
the sand particle goes inside. It's not
Mm.
a problem. We have developed a technology where it doesn't. So you don't get this technology anywhere else. You have to be an engineer to think this one.
Right, right.
So what I want to mean is the engineering, the mechanical will not get vanish or will not be taken over by anybody.
Correct.
You are in see AI is intelligence. It's a collective intelligence.
Mm.
It's my yours our intelligence. So whatever intelligence we have, so and we are all in intelligence because we understand, we touch and feel what happens there.
Correct,
The
correct.
AI cannot do it.
Mm.
So mechanical industry will still have a lot of scope. It will be still design. So what's happening is people think I'll just go for design, but they should need to understand the design to manufacturing.
Mm.
So there are different. So one is design to manufacturing, there's new product development, then manufacturing to mass manufacturing. So
Mm. Correct.
manufacturing, mass manufacturing is a totally different thing.
End game. Mm.
So people, okay, I just give it to somebody who is there, who else is there, how to what machine I have to put it there. So,
Mm.
all those things would be still be there, and it is going to have more and more requirement in the future.
Right. Okay.
Because the more technology, the more automation. See, to everything you are talking automation. The more automation you are talking about it, you need more mechanical engineers.
More mechanical. Yeah, that's what I was thinking.
Today, mechanical is not isolated.
Mm.
I mean, earlier you had only mechanical parts, you had only electric parts, you had software. So it was all like, so today it's all three combined.
Mm.
So you need mechanical engineering, but you should understand how the electronics going to control this one and how software is going to control electronics and mechanical.
Right, 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 right.
So the core remains still the same. Mechanical will remain the same as the core there.
Understood. Understood. That is interesting. So good. So I think what you just suggested that the fundamentals are not going to change, and mechanical engineers continue to focus on what their core strength area is, which is mechanical. I think, and as you rightly pointed out, when more machines are involved, you need actually more mechanical engineers than ever before because there will be more intelligent machines, maybe involving you leveraging some electronics for command and control. But in the end, mechanically, even robotics is an example of an electromechanical automation only. So yeah, so I think those are going to play a big role, and there is no.
Decision making, as I said, no, like quality. See, if you assuming there is a automation quality control,
Mm,
it will measure the diameter. Assuming it measure diameter, it says the diameter 10 mm plus minus 0.1 mm is the tolerance. If it is
yeah,
0.1001 also it will reject because as per it has to. But a
yeah, correct,
machine
correct, correct.
knows 1 micron will not
One
impact
more
this
great thing. Okay.
because assuming there is a flange where it's not critical at all for the I would say for the critical. It's just a flange to mount it. It's not function criticality. It's just for
Mm.
mounting. So if there are deviation of it is the tolerance has gone by 0.1 to 0.2, or it will not impact
Right, it's not going to make a bunch of it.
because it's just for mounting. But if you put a automation there, it says okay, it is plus minus zero point 0.2, it is rejected. But then you need an engineer to say, okay, this is
Mm.
okay, not
Exactly.
it has to be rejected. So therefore, the decision making still remains with the human.
Remains with, yeah, understood. Perfect. Vinash, let me come back to your NASCOM experience now. So that seems very interesting decision point for me and an interesting career choice. From hardcore manufacturing and industry, you move to an industry body, NASCOM, where you were facilitating. So I am assuming you played a role of a facilitator, kind of a role maybe there. So what was your thought behind making this career change? And second part to the question is, how did this experience enrich you as a professional?
So for this, I need to go one step back. In Bosch, I was my last role in Bosch was I was managing. I was part of sales and marketing department.
Uh,
So that in Bosch, there's a new department formed that time where Bosch has different BUs, business units. So diesel, gasoline, starter
right.
generation,
Oh,
automotive
uh,
electronics. All there are different BUs. Each BU were reporting to their verticals in Germany, and they were acting independently to customer. Like if you're taking Tata Motors buys diesel engine, Tata Motors buys starter alternator, Tata Motor buys motors for your
mm,
wiper blades, they buy ECU. So, but
mm,
there are sales engineers there. So they're talking to, if a diesel guys goes, he talk about diesel product. If electronic guys goes, he talk about electronics. So everyone is talking to one. So Bosch got a concept of horizontal deployment. So they said there will be executive officers where for Tata Motors, there will be one sales guy. So he will
uh,
talk to internal BU of Bosch because Bosch has a lot of complex organizations. So he will talk internal
right.
within Bosch, and then he will go along with the. So for example, if he goes along with the diesel guys, and they're
Mm,
talking about a new project coming in Tata Motors, he knows very well that they also require electronics. They also require Viper motors.
correct,
So
correct.
he ensures to get all this. He present to customers that what all Bosch as a Bosch can give it to
Provide. Mhm.
provide them, and then whatever is there, we'll ensure that the Bosch gets a bigger chunk of the automotive business. So that was the idea where Bosch created this executive officer organization. They called. So I was the executive resident to the head of a senior vice president of Bosch in that one.
Oh, okay.
So I was managing this. So I was managing both sales, marketing, everything. I was managing there.
Mhm.
So there are like 8 BUs of Bosch been was working there. So how to manage, how to work with different people because nobody's reporting here. Once again, it's a matrix organization. Nobody reports to you, but still
Correct,
you.
correct. But you have to get things done. Okay, interesting.
So it's quite challenging was there, get it done, including receivables was there with us because customer receivables also was there with us. And
Mhm.
when you go for a marketing event, then you say, how do you represent as a Bosch than representing one division there? So whenever you're showcasing at the customer, so you get all the Bosch divisions together and showcase what Bosch can bring to the table. So this was a good role what I was done. So when I got the NASCOM thing, NASCOM was much bigger than this because automotive was one BU there.
Right.
So
Automotive one.
automotive, construction equipment, then aerospace and electronics, all these things were there. And I was been with Bosch. I started my career with Bosch. Was there with Bosch for almost 18 years. So I said, let me venture out outside of Bosch. And this looks something interesting because it is from the always I was inward looking. I mean, you are inside the industry, you know what's happening inside the industry. But when you
Hmm.
go out to like a NASCOM where you're from outside of the industry.
Okay, right.
And you see different industry, different behavior. See here, Bosch would have different views, but the whole DNA would remain same because the processes are
Correct,
driven by the central.
correct, correct, correct,
It
correct.
cannot change. There could be some smaller difference, but the remaining same. Like all Indians, we are almost same. But then you go outside. the India looks different because it could be a different states, different language, but we almost all have same thinking, same like spices, all those things. So I said, why don't you go out of Bosch and look outward side of the industry? That is how I took that jump into NASCOM to understand how does the industry look like from. The good point is, in the last 16 years in Bosch, the number of people I met was 10% of the, or I would say 10x the people I met in NASCOM in 2 years.
Wow, really?
Yeah. So 10x of people who you meet, and then you meet from different industry, different people. I mean, you are every day meeting one other company.
That is a phenomenal outreach. Amazing.
And the learning in the 2 years, I would say, was humongous. It's like
So,
doing something.
Avinash, so what basically was your primary? So, as just for clarity for all of us to understand, so what kind of what are the objectives of NASCOM like bodies, like industrial bodies, and what is the purpose? Like, what was your purpose when you were talking to all these different industry bodies and people?
See, when the NASCOM started in late 80s and 90s, earlier 90s, the idea was NASCOM, because the idea was booming that time.
Okay.
So there was no representation from the IT industry to the government or anywhere to the outside world
Oh.
to demonstrate
Mm,
what's happening in the
mm,
IT industry was there. So
mm.
that is where NASCOM played a major role to make India as a IT hub, and they could create so many employment, and then I mean, they could
Right.
create momentum, work with the government, made policies because there were no policies at that time. For example, there were labor policies which was typically for manufacturing industry. Then
Mm.
NASCOM got a labor policy for labor, I mean for IT industry in
Okay.
general. Where
Mm-hmm.
the BPO had no thing. So all those things they got it done, which is is the business of IT industries in the country, and they could make such a big, I mean,
Correct.
100 billion,
Correct. Correct. Yeah.
100 billion industry, one of the highest exporter, which
Correct.
in India, which does the IT industry for it. So that is the NASCOM did that wonderful job in doing it. So since the focus was IT industry and everything, then they said engineering industry is also a growing area at that time, during that time when I joined in
Mm-hmm.
2012, 13, the engineering industry were growing that time. So it was happening in pockets, like for example, TI was there in Bangalore that
Right.
time.
Right.
Was there, Continental was there, automotive, Airbus, Boeings were there. Then you had JCBs who started their engineering. So what happened? Most of the manufacturing industry, they started their manufacturing in India, but the engineering was still in their parent. They did
Okay.
not
Okay.
move
Move
there.
the engineering over here did not happen. Okay.
Very few were there. Like TA were the first runner in India
Ah,
who came
correct. Correct.
there. Bosch was also quite old, like Continental.
Correct.
So the whole idea was, how do we same energize this engineering industry and
Mm,
get more industry and get more businesses, and then also demonstrate this to the Indian companies. For example, it could be HAL, it could be BEL, who are also looking for engineering support in India, where we
right.
could connect this industry where they're doing for Boeings and Airbus, can they do it for HAL and all those things, HALs and Quest, all
Mm,
those things can do it.
mm.
So that was the idea of it was
Interesting.
just started 1.5, 2 years back, and then idea was to create this. And you mentioned in the introduction that we created special interest group.
Ah,
So we wanted to understand this. One side, it's not one size fit all. The construction equipment industry is completely different from automotive industry to the aerospace industry.
correct.
So aerospace industry, when I to join and I was talking to the aerospace who works for these services industry. They were predominantly doing this. I would say the drawing alteration or the engineering change equations come from the industry, and they were working on it. How
Mm,
do they can do for value addition next? So can they
right.
how can they do
Right.
design more of a design phase, all those things? How do we demonstrate this? So a lot
Mm,
of companies requested, for example, few companies wanted to set up their center in India. So they wanted to understand what the capabilities in India possess, what
mm.
other companies are doing it. In fact, we did a McKinsey report during my tenure to
Right.
showcase what is the value chain or what is the value addition Indian
Oh, interesting.
companies in India are doing it. Where are they in the value chain? Are they still at the bottom of the value chain, or they are the middle, top? So
Okay.
it can encourage more and more captives to come to India and do it. And of course, for Indian companies to move to that level. So where are the captives? How the captives are doing? How the Indian industry, Indian companies are doing it? For
Mm,
example, just to give an example here, how where is the Bosch and where is HCL in the
right. Right. Oh, right.
value chain
Okay.
of the
Got it. Got
company.
it. Yeah.
How HL can come up to Bosch, or Bosch can they move up the ladder. So just to give an example here. So that was the idea to create the special interest group was done. So during that time, the IoT was a buzzword was happening,
Mm.
but it was very very fragmented. So IoT was everywhere. People are talking, but there was no single place where you could get all the companies together or the startups to come together. And the
Mm.
NASCOM had just started the 10K startup during that time.
Ah, correct. Correct.
So see, typically for a IT product startup, you need laptops and you need some servers to do it. But for an IoT startup, you need a lot of other equipment. You need
Correct.
oscilloscopes, you need some
Mm.
sensors, you need to play around this. And just to buy oscilloscope, it will cost you a lakh and thing. And you use for few days and you cannot use it later. So the idea was to create a workshop or create a place where people can come with the idea and go to the product. Here I'm
Yeah.
talking about physical product, not
Mm.
just a
Correct.
software product.
Correct.
Of course, you need so IoT had a software and hardware to it. So this was the background. We consulted industry. A lot of industry gave the inputs. What are the equipment you need to
Mm.
build the IoT thing?
Mm.
Created a budget out of it, and industry was ready to fund 50% of the money what was coming to the budget there.
Mm.
So once there was a meeting called by Department of Electronics and IT in New Delhi. They want
Okay.
to understand how the IoT works and everything.
Oh,
So
okay.
I
Mm.
went for the meeting. There was a huge group and everyone was there. And there was discussion happening. People are presenting everything. Uh, Before lunch, I said, I want 5 minutes of time to present. I was not, I said, okay, please go ahead and do it. I made a 5 minute presentation. After that presentation, the secretary, Mr. Ajay Gupta, I think so, and he is currently, if I'm not wrong, the defense secretary. Within 5 minutes, after 5 minutes, he said, Avinash, can we meet after lunch? He said.
Mm.
He said, after lunch, I went to his cabin and he said, you guys have prepared so advanced. Tell us what we can do to
Good.
fund this one.
Oh, fantastic.
I mean, I was shocked. He said, please tell us what do you want. I was not prepared for that. I was not. He said, sir, I have not prepared. I said, we have made a budget of X. He said, Avinash, you are thinking too less. It's not realistic. Please go back, rework, and get back to me. We will do it. So when we came back, reworked with the industry and said, what do we do and all those things. Because he said 3 years you need to run this thing and all those things.
Oh, okay. Nice.
Then after we made a budget and presented to him, he said, okay, let's do it.
Okay.
So he said we'll get one more Ethernet or something. Is one more organization. We got together. He said, okay, we'll NASCOM and this will run this one. So let's start in Bangalore. It was such a fast decision. I never
Nice.
expected that it can happen. Fantastic. It moved and they came here. Everything finalized and what equipments we need to buy. Everything was identified. Place was identified, and I think government of Karnataka then
Mm.
said that they are going to fund the location for this one.
Nice.
So it was up and running there. So
Oh, that's phenomenal. Good.
yeah, yeah. So that was
Really good. Yeah.
one of the thing as a NASCOM did for the industry. So that is how a lot of IoT. The idea is to people should come out with the idea and go out with the product.
Nice. Pretty good. Yeah. I've seen that space. I think it is very nice that we could really build that out quickly.
So that was the idea of doing it in NASCOM.
Nice. So Avinash, coming to your current role now, you have taken up a CEO role now at Vyoda. So tell us about what is the mission of Vyoda and what is your role now to where are you taking the things with Vyoda?
Okay, so when I joined Vyoda, there was a concept that time that we had concept from Israel. So they had a concept of developing a solar-based positive displacement piston pump. So
Okay.
the current technology available in the market is a centrifugal pump, which all of us knows. That pump is an ideal pump for a grid connection where you have constant power. So that is
Okay.
suitable for a grid connection. And it has own its inabilities and efficiency, all those things. So any centrifugal pump has efficiency of 35 to 40% an average is there.
Okay.
But still, which is much lesser. But if you look at a good product, it's 35 to 40%. That was a force fit for a solar application, because solar is not a constant power; it's a variable power.
Correct.
The sun
Correct. Yeah. So
early
sun
in the
will go
morning,
up,
then
down.
goes up.
Yeah.
Peak. It's a bell curve. You have this bell
Yeah.
curve. Typically, you have a bell curve for this solar thing. So we want to develop a pump for exclusive for solar, where
Hmm.
your efficiency remains the same throughout the day, because power, in spite of power fluctuation, the efficiency cannot change. A
Hmm.
centrifugal pump, what happens is the efficiency, there is something called as best efficiency point, BEP they call it.
Okay.
That works only at a current, at a constant head and a constant power.
Okay.
Or else it's a parabolic curve.
Hmm.
So anything changes. So your head changes, head is water, how much water you are pumping out to the head is. Or
Hmm.
your power changes, your efficiency drops either in a parabolic.
Okay. Okay. Okay.
So in a solar application, your power is never a constant.
Hmm.
Your power is always a variable from morning to evening. So your
Correct.
efficiency cannot be constant. And your head also varies because the water table moves up and
Hmm.
down in a
True.
day, morning
Hmm.
to evening. So because there was no technology available, there was a force fit they were having it. Just to give an analogy, for example, for a 5 HP pump,
Hmm.
5 HP is 3.75 kilowatt if converted into kilowatt. So for a 5 HP pump, they use 5 kilowatt of power to run
Okay.
the pump. So that
Okay.
means you're already adding energy. So for a 3.75 kilowatt motor, you're using 5 kilowatt of
Psychology. Okay. Okay. Hmm.
to just to overcome your inefficiency, or just trying to increase your power.
Hmm. Hmm.
So we have developed a pump where we say to give a 5 HP equivalent water output. For example, Government of India, Ministry of New and Renewable Energy, MNRE,
Hmm.
has done some benchmarking. For example, at 100-meter deep, the pump is 100-meter deep with 5 kilowatt of power for a 5 HP system. It has to give 70,000 liters of water per day.
Okay.
So what we said is, we let us not change the depth and the water output, because let us keep that as sacrosanct.
Okay. Hmm.
Let's say how much input power we can reduce.
Okay. Interesting.
So
Right.
from 4.8 kilowatt, using 4.8 kilowatt at 100 meters depth, they give 70,000 liters of water.
Hmm.
For the same amount of water, 70,000, at same depth 100 meters, we use 3.3 kilowatt.
Oh, so immediate efficiency you brought in.
Yeah. So it's almost like we use like 40% less panels.
Exactly. Yeah.
So, and then also the water table, and typically in a cloudy condition, people ask what happens in cloudy. See, when it rains, you don't drink water to farm in the for their farms. That's okay.
Okay. Okay.
But what happens in a cloudy condition?
Uh,
When you're sick, there is something called as irradiance they calculate. Irradiance is always irradiance is a measurement of your illuminity of your sun. How much
okay.
power is
Okay.
generated on a per
Hmm.
square meter of solar panel.
Oh, okay. Hmm.
That is the irradiance they call there.
Okay.
Under standard condition, for example, if you buy a car, they will tell your car will give you 18 kilometers per liter
Hmm.
as per ARAI.
Correct. Correct. Yeah.
But in ARAI, which is in Pune, so you know it is driven on a straight road, no
Ah,
hump, no
correct.
pothole, no car,
Yeah.
everything. And your car will never give you 18 kilometers in your lifetime. In the
True.
Indian road, in your traffic, you are breaking all those things. This is exactly the same thing. So what I said, 77 liters, it is at 7.15 kilowatt per meter square, which is ideal condition, which is a lab condition.
Hmm. Okay.
But if you look at in India, the average irradiance is 5.5 kilowatt.
Oh, okay.
That is the average in India.
Hmm.
7.15 goes very seldom in Rajasthan, Gujarat, 1 or 2 days in a year.
Oh, okay.
But typically 5.5 is there, and the temperature also plays a major role there, because people think solar panel, no, as a
Hmm.
temperature increase, it gives more power. It is not so.
Oh, okay.
We are all using solar water heater at home, because as the temperature rises, we get good hot water. But in a solar panel, every degree rise has a reduction of 0.04 degree percentage of power generation.
Oh, okay.
So 25 of the panel temperature is ideal to generate your power,
Hmm. I
and
see.
it doesn't. You never have 25. So in summer, it goes like 40, 48,
Yeah,
40.
it's 40 degrees now, right?
That is ambient temperature. But your solar temperature will be much more, because you have a glass on top of it. So it has much
Okay.
more higher
Yeah, it has
temperature.
much more higher temperature. True, true.
So it goes up to 70, 72 degrees. So your cell temperature.
Oh, okay.
So it almost like 20% you have reduction in your power generation. So
Hmm.
to compensate all those things, they have this 30%, 40% more panels. And in cloudy, what happens? It has like 3.54 irradiance maximum in a cloudy thing. But you still need to water your plant. Your water may require lesser plant because it is cloudy, but you still need to water your plants.
Correct.
During that time, central pump cannot even pump any water because central pump is like until as you don't get to a particular RPM, you don't cannot pump the because you don't get a centrifuge force there to push the water.
Okay. Okay. Okay.
In a constant power, what happens in a grid connection, they reach that RPM very faster and they start pushing the water out. It's simple.
Okay.
But here, until they don't reach the, they get the power until they don't reach the RPM, which is equivalent to power. They don't pump the water out. So
Okay.
typically they start like 8:30 in the morning because then they get the power to pump the water and they go up to 3:30 and then they stop it. Our pump we have witnessed starting at 6:30 in the morning,
Okay.
goes up to 6 o'clock in the evening.
Oh, okay. 12 hours.
So hypothetically, if you are running at 1 RPM also, the water has to go out because it is a piston pump.
Okay.
So for common man to understand, you have this hand pumps you have seen.
Hand pump side. Yeah. Yeah.
So hand pumps is in your stroking one pump, there will be suction. The next stroke, it will have a delivery.
Correct.
In our case, so we have piston which moves up and down. We have double cylinder there. So when the piston is moving up, the water sucks and the other chamber water goes out. When the piston is moving up, the second chamber water is filling up, the one chamber goes out. So it's a continuous movement of the piston.
Continuous flow. Okay.
So it's a
That's nice.
bidirectional piston pump. So bidirectional means it pumps the piston pump both the direction.
Understood. Okay. Nice.
So that is how we are able to gain the efficiency.
Oh, interesting.
So
Interesting.
we talk about 70% constant efficiency throughout the day.
Nice. That is phenomenal achievement. So I'm sure that this all is patented. So where are you currently deploying now, sir?
So currently we are deployed in and around Mysore and then in Rajasthan because government of India before approving the technology and Rajasthan being a harsh condition, I told you, no, the sand particle is what they were worried about it.
Oh, okay. Okay.
They said, please deploy in Rajasthan to see how does it behave. So it's almost running 2 years in Rajasthan and more than 4 years in and around Mysore now. So it's running quite efficiently. And I have a video where one of the farmer has sent, where in January in Rajasthan it is completely hasty, absolutely no sun, and our pump is running at 100 meters deep.
Oh, fantastic. So that's a
And
very
the video is shared by farmer, not by us.
yeah.
So absolutely, you don't see any because Rajasthan, it becomes completely haste in January. So you don't see any sunlight, but still our pump is running because the whatever limited illuminati it is having, irradiance it is having. So it could
Nice.
be 1.52, it could be that time.
That is interesting. I think very nice. I wish you all the success with this product. I think very interesting and innovative product you brought in.
Yeah.
So, Avinash, so do you, I want to, with this one, I want to, since you are actually working on product innovations right now. So, what I would like your comment on what kind of engineers you would like to work with as a product innovation company. What is it that you desire from mechanical engineers or engineering guys who are now coming and joining in the industry? What does it require for them to work in a company like yours?
See, two aspects are quite important for engineering. One is, of course, a technical aspect, which is quite common. You should understand technology, technical designing everything. Second thing is attitude, because today, what I observe at least, a design engineer doesn't want to go to shop floor. He doesn't want to make hand dirty.
Okay.
He says, okay, I've done the design, so it's shop floor duty to assemble and give me a feedback. So everyone wants to be a manager role. Everyone wants to get the feedback and nobody wants to make their hand dirty. So what I would desire is when I said no first example, when I made my hand dirty and removed the fixture, I could not assemble it back. That is what happened. If somebody has designed a product, he should know and go and see how the product is there. He should try to assemble by himself. Then he will know the real difficulty. If you
Right.
don't do it by yourself, you will not understand difficulty.
Hmm.
Because you get, see, always second-hand information, always second-hand information. It's not perfect information. There will be some truncated information in between. You need to design, you need to say, I'm the owner of this product. I will go and assemble the product. I will do the assembly of the product. Similarly, if somebody is coming to manufacturing assembly shop floor, before he's giving it to operators to assemble it, he should know how the assembly looks like. I want to be witness. I want to do my hand. I should assemble it. Then he can do a good process. He can improve the process there. He could bring a new fixturing. He could get a new tool. All those things. Today, what I see is everyone wants to be a manager.
Okay.
I will deploy, I will delegate, I will sit, I will understand. So I would say, see, technical people do understand, but until unless you don't make your hand dirty, you
Mm.
cannot improvise on this one. So that is what, see, that time were we were forced, we did by our interest. Whatever happened for good for us.
Right, right.
So today, after 30 years also, if I sit here, if there's a problem, I can tell if the problem is genuine or if he's just making up the stories.
Understood.
To tell that, you have to make your hand dirty.
Yeah, yeah. So you have to be hands-on guy. You should
And
know
you have to be hands-on guy.
completely hands-on. Yeah.
You have to be hands-on guy. And don't depend, your basics cannot change.
Mm.
Your fundamentals cannot change.
Right.
The machine design, your design, that handbook still remains same. You need to know how to do it. Don't just depend everything on your Excel sheets and
Right. Understood.
so please know, right to know how to do the calculations.
Mm.
Because once you know, no, then if somebody has done the calculation, you know what is right, what is wrong. Or else people will take you for granted.
So Avinash, so what is your view on the manufacturing industry or agri-tech? You are now also part of agri-tech. So, but a broader view on where the industry is and where do you think are the opportunities for work? And how is the industry shaping up by and large from your view?
See, one thing we missed out in India was industrialization. As India, we missed out industrialization. I would say 70s, 80s, industrialization. We jumped into service industry. 90s. By 90s, we
Ah,
are
correct. Yeah, yeah, yeah.
service industry and service industry, and now we are facing the heat. Now that is why people talk about China, India, China, US trade war, all those things, and those guys went ahead and doing it. The good part is now we are at least now we are realized and we want to bring the industrialization, make in India. There's a big push in make in India,
Mm,
and this offset policy has been now really been enforced with the other companies to put their manufacturing
mm,
thing. And
mm.
China plus one policy, people are talking about it, and we have a manpower. The biggest strength is our manpower. It's not a weakness, I would say. It's a strength is manpower. So if you are able to, that is what the government is pushing, and I personally believe that more and more industry is going to come to India
Okay.
because since we have young generation, one good thing in NASCOM also understood the Indian average population is 26, where Japan is already 40, 45.
Mm.
So you need people to work. So it could be any field for that matter. I'm not telling it's automotive alone or aerospace alone. It
Mm,
could be agriculture would be a biggest thing required in the
mm.
market. I would say in the because the more and more automation happening in agriculture because today agriculture is shrinking. As I would say, agriculture is shrinking. People want to come out of agriculture because of both labor cost and non-profitability and all those things. So more and more automation happens in
Okay.
agriculture. So you have a lot of innovation happening. See what happens. Look, there is if you ask, there is a lot of automation in agriculture in the Western world. But those guys cultivate like 100, 200 acres of land.
Correct. Huh.
In India, I've met a lot of in India. It's we are all say small or medium scale agriculture where the farm size is less than hectare. Like the farmer wants like 2.5, 1 acre land.
1 acre. Okay. Mm.
So I cannot go and telling that you buy a machine which is costing you 10 lakhs.
Mm. True.
It cannot work like that for him to buy equipment of 10 lakhs because he cannot get back that in next 10 years. Also, he cannot get that money. So if
Mm.
you're able to get a automation of a very small cost, 10,000 rupees, make it automation, 10,000 rupees, 15,000 rupees automation, where his life
Mm.
become easier and he's able to generate on his own, where he and his family can earn money on it. That
Mm.
is the source, I would say, sweet spot in India where you have a big market. It's the bottom of the pyramid.
Mm.
If you're able to cater small and marginal farmers, if you're able to
Mm.
build automation or I don't say automation, you can build equipments. I don't say
Equipment
automation.
for them.
If you're
Mm.
able to build equipment,
Understood.
uh, these areas make their life easier. That's a big market in the country today.
Interesting.
So
Okay.
it's a big market in the agriculture because there also become nucleus families. There also become small families. The farmer has only one or two kids. Not that earlier we had 10, 15 kids
Mm.
where two would be working. They don't have today. And they
Right.
want their kids to be educated. They want the kid to come to the city and they want the kid to be in IT engineering and go out and do it.
Mm.
So if you're able to do these small with equipments for agriculture where you're benefiting smaller and the market is quite huge there. The
Okay.
80% of India is once again 80-20 rule.
Correct.
80% of farmer has this small and marginal. The 20% only large farmers.
Mm.
So 80%, if you're able to cater it, you can always do it. And now they're talking about organic farming, so you can do something in organic farming also.
Okay. Okay.
So how can you make this into a, so I would say this is a market where they can do it. And of course, as I said, the industry, manufacturing industry, people are looking into manufacturing industry. Electronics is going to a big going up in India. Semiconductor would be a big industry. So if you want to have semiconductor, then mechanical always would be there as a associated.
Yeah. Yeah.
So today you cannot differentiate electronics, mechanical, and software. I can
Correct. I think all is kind of coming together for into a
look at our own system. We have a mechanical pump, we have a motor, electrical motor, we have electronics which is inbuilt in that one, and we need software to understand because we do the up and down stroke and change the direction. So the software is very much required there to do it.
Hmm.
So it's combination of these three. It's a complete pump we have developed it. So agriculture is a big industry. Manufacturing we can always have a big space for to do it if you are able to venture into it.
So understood. So you are talking about manufacturing, agri-tech, irrespective of the industry. I think there is a lot of scope, is what you are saying.
Yes.
So, Avinash, now coming to the what I would just want to understand some key habits or your traits or activities that you do to stay ahead, no? Keep be informed. How do you try to stay ahead of the game? How to, because the industry is changing, so much volatility in the world today. How do you are leading a company here? So, what is your secret of, trying to bring a little bit more predictability in the work that you do? How do you try to stay ahead in the game?
See, today the buzzword is AI. So I'm reading a lot of AI, what's happening in the AI world, and how
Okay.
can this be incorporated into my industry, manufacturing industry. If I just tell you, in earlier days, all our quality documents, everything were recorded, manually done, kept it in there, and most of them are memory driven. So if I ask somebody, my quality engineer, what he said, sir, there is some there, I'll take out the quality document and do it. So if you're able to bring AI, in this case, AI can do help you a lot of things.
Okay.
So it can get all your previous quality records and then it can give you the insights what's happening there. So it could
Okay.
help your design. So from design to manufacturing, it can help you to build this one. Just an example. Or today we do a lot of pumps we produce, we go to market everything, and we need to keep track of each pump, what is happening, what is the status, all those things. If we are able to train AI to get all the documents and give us instant alerts what's happening, and if there is, I mean, if you heard about car recalls, I mean, how many recalls?
Ah, yep, yep.
So if you're able to do a predictive analysis using AI, that will
Hmm.
give more customer will be more happy that you're doing predictive analysis
Correct.
than after you complaining and preventive analysis, whatever predictive or preventive
Hmm.
analysis. So AI is, I'm trying to understand how AI can help into manufacturing process. I mean, to ease the manufacturing, and I would say
Okay.
the mundane jobs, which is more human oriented, laborious job, you can put it
How
to
can
AI
you
and
basically automate those? Hmm.
automate those things. I'm working on
Okay.
those things, and of course, the new technology evolving in the manufacturing processes, all those things. Definitely, I would look
You,
into.
you would look into that. Okay.
Just for example, welding is a big subject. People know what welding is, but today welding automation has grown leaps and bounds.
Really? I
Uh,
have no
so,
idea.
so leaps and bounds, welding has grown. So all those things. See, any process has to do two things for an organization. It has to reduce cost. It has to improve quality.
Hmm. Right.
Quality and cost go hand in glove. People think quality is always expensive. Actually, quality is cheap. If you are able to maintain good quality, your product is cheap. People don't understand cost of quality.
Hmm.
I'm talking direct cost. I'm not talking indirect cost. Indirect cost is perception. All those things. People not buying your product is indirect cost. But just assuming there's a recall of your product, how much money you have to spend to recall, rework,
True.
send it back.
True.
Your reputation is lost. I'm not talking that tangential loss, what you get, but direct loss, what I'm doing. So, if you're able to, any process is going to improve your cost and quality, and that has to be your focus. So, you need to look at what process can do it, how you can do the improvise your process, all those things. You're looking into it, and how much automation you can build, how much reduce your manual intervention, how much you can do automatic failure detection. All those
Hmm.
things can help your quality improvement.
Okay. Nice. So what do you think now, this scenario in picture, what are the key skills and capabilities that students and even colleges need to work on, to stay current in the game? The guys who are coming out and looking to join the industry and make a difference, what would you suggest to them in terms of being prepared for the industry in a better way than what they are today?
See, I may be wrong because during NASCOM days, I have interacted with few industries. I don't see a big change that happened in the syllabus. I mean, because
Okay.
fundamentals has to be there.
Yeah, yeah.
If the education institute academia can uh, teach the students about new technology evolving in manufacturing.
Okay.
New technology doesn't mean you teach them C, C++, Java, Python, all those things. I don't.
You're
I'm
talking
not
about
saying
manufacturing methods.
manufacturing methods. Teach them the manufacturing methods, what's coming, the latest thing. Uh, let them work in the internship in the these manufacturing industries, hands-on thing, not in design. Because today what happens is a mechanical engineer, they think they can go for design engineering.
Okay.
But there's a lot of happening in the manufacturing side. So you understand what's in the latest process happening, process improvements happening, and
Okay.
what is happening in a lot of quality automation, what's happening in a lot of quality
Mhm.
automation, what improvement we can do. So if
Interesting.
you're able to demonstrate, for example, see, if I talk about Pokoyoke, which is fail-proof in Japanese thing, so teach them about what the thinking has to be in that direction. So if I'm able to build a process, how many fail-proof or Pokoyoke I put into that manufacturing line. So
Okay.
there is the always the best example of a Pokoyoke given to us when we are trained. You have a train level crossing in a train. So you put a gate there, barrier there. That is first of all, but still people, in India, people go around it. They're still, before it closes. The third level
Perfect.
is you construct a bridge where the train goes up, you go down. So absolutely there are accidents.
Ah, okay. Okay. Understood.
So I would say first level is put a light there. So when it's red light, nobody crosses, but still
Mm.
people crosses. That is first level. Second level, put a gate, so still you don't. Third, I mean, people still go. Third level is have a bridge over it.
Bridge over it. Mm.
So train these things into the thing, and then teach them about production system like Toyota production system, all those things. First,
Okay.
lean management, lean
Manufacturing.
manufacturing, lean manufacturing, all those things. You teach them. So I don't know. They may be taught that. I don't know how much it has been taught in the industry. So these would help them when they come, and because what happens when they come to industry, they hear like the French and Latin for them when they come to the
Okay.
industry.
Mm. That
So
becomes tougher for them.
like Six Sigma, we talk about Six Sigma. So
Yeah.
have Six Sigma project. They do a Six Sigma project. Let them have basic level of Six Sigma being done at the college, which is easy for them to do it. So when they come to our industry, they can apply all those things. I would say, I mean, I may be wrong because I'm not. I mean, I'm outdated now in the academia. What's happening there? So if they're
Okay.
doing it, I would say they can definitely take these
No, I
things.
think at least you spelled out your expectation. I think that is fair. If they're doing it, it's good. But I think as an industry leader, I think you have spelled out an expectation in terms of what they can be prepared for. So I think that's a great input to have. And finally, Avinash, I think I want your mantra of success. What is like a few points you can maybe elaborate in terms of, in general, advice, like what is the your secret of professional success which others can learn from?
See, examples are given. So one is listen to others first. Listen to your, I would say, experienced person. So that's important. Don't hesitate to make your hand dirty.
Ah,
I would say
you have
that's
emphasized that many
uh,
times. Yes.
most thing I see missing with the people here. They don't make hand dirty. And if somebody says there's wrong, please first say, accept it, go back, work on it, and then you can go and tell the person if he's wrong or you're wrong. Don't defend that you are always right and that guy is always the.
Yeah. Yeah.
And see, keep eyes and ears open. What's happening in the market? What's happening in the
Hmm.
industry? Your industry. Get updated it and don't lag behind what's happening there because the more you get updated, you can deploy it in your function, your company, all those things. This is what at least I have followed and in my life, and this is where I think this is one of the this is why I've been successful. I would say whatever success I've achieved, I would say this have helped me to bring success.
Fantastic, Avinash. I think thank you so much for your time today. I think you have been given out some great insights into what your expectations are, what has been your mantra of success. I think you have very candidly spoken, and I thank you for that. And I
Thanks,
think
man. Thanks for spending the time.
this will be very insightful. I'm sure this discussion would prove very insightful for a lot of people.
Thanks, Jimmy.